You'll be asked to simplify a radical. In order to do so, you have to understand the basics of what is in a radical. So there are four major parts, as you can see on here. The radicand is the number, the value, the expression that is inside the radical symbol. So just this symbol itself is called the radical, but the whole quantity is also called the radical. So that's why it could be confusing. But when we ask you to simplify a radical, we are going to want you to simplify the entire thing, no matter what is a radicand or no matter what the index is. Right? And so this is a 3 here, so that's why it's called the cubed root of 27, because this is a 3 or something that is undoing something which is cubed. Sometimes some students will say something weird like the third square root of. This is not a square root symbol, it's a radical symbol. What the index is determines what sort of root it is. So since this index is 3, that's why it is a cubed root of 27, which would be equal to 3 because 3 times 3 times 3 is equal to 27. And since the index here of a 3 matches with the 3 of those that are in there, that's why it is equal to 3. So I want to start off with 3 basic radical examples, ones that are pretty simple to simplify. And obviously the first one is what we would call the square root of 16. Since there is no number written there, the index is implied that it is a 2. Now you don't have to write a 2 there in order for it to square root, so either there is a 2 or it's not one written there at all, it's implied to be a square root. And of course, since 16 is equal to 4 times 4, then the square root of that would be equal to 4. And you guys all know that, but that's the example. So now we have, for the second example, you have a cubed root of 64. So when we think about 64, well, we know, or we should know, that that is equal to 4 times 4 times 4. There are 3 of them in the cubed root, and so that's why that also simplifies to 4, because there are 3 different 4s inside there. And then for the final example, we have the 4th root of 81. So you have the 4th root there. So you're looking about what multiplies to 81 4 times, and that would be 3 times 3 times 3 times 3. So 3 times itself 4 times. Then when you do the 4th root, those all cancel out to be equal to 3. So as you can see, if you have a square root, then you're looking for 2 4s inside to equal 4. If you have a cubed root, then you're looking for 3 of those to be equal to on the outside. And a 4th root, you're looking for 4 of them. So 4 3s then multiplied to 81. So that's why the 4th root is equal to 3. So hopefully that helps us think about what the product property of radicals is, which is when if you have a product inside a radical, what you're able to do is break it down into separate radicals itself. I think of this in the fact that a radical itself is a multiplication concept. You're trying to find out what multiplied by itself several times, just like those square root and cube root examples will cancel out. And so since the square root or any sort of radical is a multiplication concept, you can split it up into separate radicals. And that's an extremely important product property that will be meaningful for us as we go through our simplification problems. And a key thing to remember is that it doesn't matter what the index is up here. You can put any number there and it'll be the same for all of the other different radicals. So I could put a 5 here, and then that means that there'd be a 5 in each of these individual radicals as well. No matter what that index is, square root, cube root, 5th root, that's going to be the same index for all these different parts. Again, the product property of radicals is an extremely important property for us as we simplify, as you'll see in our next examples. Now let's take a look at an example for simplifying radicals. Now most of the time when we ask you to simplify a radical, we're just going to be focusing on square roots to keep it simple and basic. Although these same concepts, if you understand them, could be applied to a cubic root, 4th root, 5th root, or any other root, but we're going to be focusing mainly on square roots. Now there are 2 common methods for us to simplify our square roots. Those methods are the perfect square method and the factor completely method. My bet is that most students are more familiar with the factoring completely method, so we will start with that one first. So let's start with the square root of 32, which factors into 2 times 16 pretty quickly. So just do the square root of all of that. You're still multiplying. So now you have the square root of 2. 16 factors into 8 times 2. So that is now underneath the square root of everything. 8 can still factor into 2 times 4. And then that's still multiplied by this 2 and multiplied by that one. It's all underneath the square root and multiplication. And one last final step of factoring is that 4 into 2 times 2. This 2 comes down, that 2 comes down, and this 2 comes down, and they're all multiplication underneath that square root. We look for our groups of 2 since this is a square root, so you have 2 of them there. You have another 2 here, and those can be pulled out of the square root because there's double of them, like we said earlier. So then you have a red 2, a blue 2, and then this 2 still stayed inside that square root, and 2 times 2 is 4, multiplied by the square root of 2, and that would be your simplified version by factoring completely, where essentially you just have to factor and factor and factor. Since this is a square root, that index there, even though unwritten, is a 2, we're looking for the doubles of those same numbers that can pull out, quote, of that radical, and then you multiply the numbers on the outside, 2 times 2, and that makes 4, and it's still multiplied by the square root of 2. Now the other method is the method I prefer, which is the perfect square method. It tends to be a little bit faster, but you do have to think a little bit more about how you're factoring. You're still going to be using factoring as your key aspect of it, since we do want to pull this out into a product, but you're going to be factoring in a very specific way. And that specific way is going to be factoring into whatever is your perfect square. So we can do this much quicker with this particular example. So as we start with the square root of 32, we still need to factor, and so when we factor, we're going to factor into 2 times 16, which is still underneath the square root. But because of the property we talked about earlier, that's the square root of 2 times the square root of 16, and we're pretty much essentially done now, because the square root of 16 is 4, right? And then the square root of 2 stays that way, and here we are, you've got square root of 2 times 4, which is the same thing as 4 times the square root of 2, and that's it. That would be your final answer at that point, 4 times the square root of 2. So you can see it's a much faster process, but the key is that remembering that you have to look for the perfect square when you're factoring. So you have to pause at the beginning, right when you look at your square root of 32 and you think, okay, well, what is the perfect square that goes into this number? So that's why I had said it's faster in the end, but you do have to pause at the beginning to think about the greatest perfect square. And when you factor that, that's a square root of each of those then, each of those factors rather. Square root of 16 is 4. Square root of 2, you can't go anymore, and you won't ever be able to go anymore if you have factored out that greatest perfect square. So in a few less steps, you can get to that final answer. Now, we don't care which method you use. You can use the factoring completely method if that's what you're more comfortable with, but we would like you to think about and try the perfect square method because you'll find that it's much more efficient. And it also is a nice way to really understand why we're pulling these 2 out in red and that 2 out in blue. It's because you're actually doing the square root of 16 as an operation to end up with 4 for your answer. So those are some examples.